Hello, my name is Count Lovenstein, and I am going to demonstrate some data bending of a video file. This is a cool way to create your own video effects without having to rely on things like Adobe After Effects or Final Cut to put plugins on that anyone who watches them will recognise. This lets you do stuff that's actually original. So, get a video here that I've created in Second Life. Fiona, the avatar, dancing around in a cyberpunk city that I've been working on. Now, you don't want to work on the original because this is not something you can really forward engineer, so there's an excellent chance the video file gets mangled. So, I'm going to use this hex editor HXD and load the copy video file into it. So, you can see here Matroska, that is the compression algorithm, MPEG-4. Basically, this here is the header of the video file. Now, you don't want to mess around with that, or else it's not going to play. It'll get wrecked. Some file formats also have information at the end, but it doesn't look like there's anything here that's any big deal. So I'm going to write down a number here. 9D3 C800, and at the beginning, just to make sure we're clear of the header file, I'll start at 1000. So, I am now going to select a block starting at 1000, ending at 9D 3C800. And what I'm going to do, where are we? There we go. I'm going to replace every 7F here with 7E. Replace all. So 5016 occurrences of 7F have been replaced with 7A. Then I'm going to save, and then I'm going to explain what I actually just did there. So let's get a spreadsheet up. So these 77F, that is hexadecimal So each one of these 2-digit numbers is a byte. Now, just to explain that, in decimal we count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then 10, back to the beginning, 11, 12, 13, 14, 15, 16, 17, 18, 19, then back to the beginning, 20, and so on. Hexadecimal is to the base 16. So it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. Then it goes back to 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 1A, 1B, 1C, 1D, 1E, 1F, then 2, then 20, so on. So the reason that that's used, computers like binary numbers, that's just zeros and ones. Humans like base 10. Base 16 is much easier to convert into binary than base 10 is. So if you talk to your computer in hex, it takes far less processing time for the computer to convert that into its own raw machine language of ones and zeros. So just to show how that works, 128, 64, 32, 16, 8, 4, 2, 1. So when you're working with bytes or words or D words or Q words, so a bit is just a 1 or a 0, 4 bits is a nibble, 8 bits is a byte, and 16 is a word, 32 is a D word, 64 is a Q word, and so on. Even to this day, where we tend to use 64-bit data buses, we still tend to talk to our computers in bytes, which are 8 bits. So, 7def, when you convert hex to binary, there we go, that'll do it. So 7def, convert. Actually, I don't really want to demonstrate that yet. I want to convert hex to decimal. So let's keep it to what humans like working with for now. 7def, convert, and you should get, there we go, 127. 7e, which is what I changed all the 7defs to, is 126. So to go back to our spreadsheet, 127 is 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, and the most significant bit there will be 0. So if I get a calculator up, hopefully 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, and there you go, 127. If the most significant bit was 1, then we'd have 255. And incidentally, that is why when you use, oops, no. That's why when you use MIDI files as an audio engineer, or you use MIDI controllers, I should say, that's why your volume faders in MIDI go from 0 to 127 rather than 255, because in MIDI the most significant bit, or MSB, is actually used as an on-off switch. Now, so this is 7F, or in decimal 127. Now, just to demonstrate the bitwise operation that I've actually done with my hex editor. So 126 would simply be with the 1 for 1, the least significant bit, turned into 0. So in a computer, of course, these aren't actually 1s and 0s, they're voltage states. So computers have transistors that act as switches in the logic gates. So if the transistor is allowing the current through, then the circuit will have a voltage. If the transistor is switching it off, then there will be no voltage. That is what your 0 and 1s are to the computer processor. So if I go back to my calculator, so this time we're adding 0 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64, and it should be 126, which it is. Now, everything that is ever done with computers, no matter what high-level language you're using, at the end of the day, it always comes down to these bitwise operations. Video files are no exception, audio files, text files, image files. They are all 0 and 1 states to the computer. The computer does not care whether it's dealing with audio, video, text, anything. That's why when you start playing around with the raw data, as I am here, it does not make a blind bit of difference to the computer that I'm editing a video with something that's not supposed to be used for editing videos. Now, let's look and see what's happened to the video now. So, very, very glitchy. VLC player is not liking it. And probably not a great deal of use to me for making up one of my music videos that I like putting on YouTube. So what I'm going to do, I'm going to take this into Shotcut. I'm going to load in the glitched video on the desktop. And stick it in here. And make another channel. and I'm going to load in the original video and put it in the overlay track. Then I'm going to hopefully remember where the hell I put my audio track, the last one I worked on. There we go. And I'll stick that in another track. And I'm going to mute the two video channels. Now, by doing that bitwise operation and changing the least significant bit in all the 7F bytes from a 1 to a 0, and by doing that turning them into 7E bytes, I have not changed the length of the video file at all. So these are going to overlay nicely on top of each other. We don't need all the extraneous guff at the end. So let's get rid of that. Now, oh, come on, there we go. Also, I don't need all the shit at the beginning. So it is also get rid of that. And on the audio file too. Now, when I'm in the video editor, I can get away with cutting off the header file because when I bounce this into one video and 2-channel stereo track at the end, when it makes a new video file, it'll generate a new header file. Now, I really don't think I want my Windows search bar. In fact, that search bar shouldn't even fucking be there. I'm sure I turned all that crap off. Anyway, I don't want it there in my final video, so let's just save this actually in case it crashes, which sometimes happens when you're editing videos. So, size, position, rotate 110 minus 40. These I can just plug these numbers straight in without looking, is because I've done this so many times that I know off by heart what the best numbers are to get rid of the bars at the top and bottom of the screen. So, if I now have a play around with the transparency here, where are we? I'll pass it. I'll take that down to 50%. So now I'm getting half the glitched video and half of the original one. And you can see there, that gives you a fun effect that is completely original, and that's just from changing the least significant bit of all the 7Fs to 7D. Obviously, you could play around with this and do all kinds of experiments until you get really cool effects. that's where the fun is. This is not difficult to do at all. You do not need to be a Bill Gates level coder to do it. You just play around with it and experiment and see what fun things pop out. And that's about all you need to know. So, call it a day there.